Hi students, this is Alex here. In this video, we are going to find the half-range Fourier sine series for the given function f of x, which is x sine x, in the interval 0, pi. The expansion formula is f of x equal to, we have summation from n equal to 1 to infinity bn into sine nx. To find bn, we use the integration, that is 2 by pi integral 0 to pi f of x into sine nx dx. Now replace f of x. So 2 by pi integral 0 to pi f of x is x sine x, and we also have into sine x, then dx. Usually we write this n term as a first term. So this is 2 by pi integral 0 to pi x into sine nx into sine x dx. Now we are going to apply a formula for this. We have a basic trigonometric formula. When we have sine x into sine y, this becomes minus 1 by 2 cos of sum of the angle, which is x plus y, minus cos of difference of the angle, which is x minus y. Now this becomes 2 by pi integral 0 to pi x bracket open minus 1 by 2 bracket open cos of sum of the angle. So when I add nx and x, we get nx plus x. By taking x common, it will become n plus 1x. So the sum of the angle is n plus 1x minus, we have to take the difference of the angle, which is n minus 1x. After subtraction, by taking x common, we get this term. Then we have dx at the end. We can cancel this 2 and 2. We can take the minus sign outside. So minus 1 by pi integral 0 to pi. We have x bracket open cos of n plus 1x minus cos of n minus 1x dx. Now we are going to use Bernoulli's formula. This is u and this is v. So u equal to x and v equal to cos of n plus 1x minus cos of n minus 1x. So u dash, its differentiation is 1, u double dash differentiation is 0. Similarly, this integration is sine of n plus 1x by n plus 1 minus sine of n minus 1x by n minus 1. Similarly, v2, this integration is minus cos of n plus 1x by n plus 1 whole square, and this will become plus cos n minus 1x by n minus 1 whole square. Now using Bernoulli's formula, Bn is minus 1 by pi, and we have u v1 minus u dash v2 plus u double dash v3 minus dot dot dot. We will replace all the terms. So outside we had minus 1 by pi, u is x, v1 is sine of n plus 1x by n plus 1 minus sine of n minus 1x by n minus 1. Then minus u dash is 1. So 1 into v2. v2 is minus cos of n plus 1x by n plus 1 whole square plus cos of n minus 1x by n minus 1 whole square. Then we have a limit 0 to pi. Now applying the upper limit, outside we had minus 1 by pi. Applying the upper limit, sine n plus 1 pi will become 0, sine n minus 1 pi will become 0. So pi into 0 totally, then minus, when I apply the pi here, minus cos n plus 1 pi by n plus 1 whole square plus cos n minus 1 pi by n minus 1 whole square. So we applied the upper limit totally. applying the lower limit, first part is 0 because there is an x, then minus cos 0 is 1 by n plus 1 whole square, again cos 0 is 1, so 1 by n minus 1 whole square. So we applied the lower limit also. Now, further simplifying this, we get minus 1 by pi. Now first term is 0, this minus I take it inside, so it will become cos n plus 1 pi, which is minus 1 whole power n plus 1 by n plus 1 whole square. Then this minus sign will go to inside, so minus 1 whole power n minus 1, cos n minus 1 pi is minus 1 whole power n minus 1 by n minus 1 whole square. Then this minus and this minus gets cancelled, become plus, but outside it is plus, but inside there is a minus sign, so minus 1 by n plus 1 whole square, again plus 1 by n minus 1 whole square. Now minus 1 whole power n plus 1 can be split into minus 1 whole power n into minus 1 whole power 1, which is actually minus of minus 1 whole power n. The same way, minus 1 whole power n minus 1 is minus 1 whole power n by minus 1, which is again minus 1 into minus 1 whole power n, because minus 1 if I multiply it is like a negative term, so minus 1 into minus 1 whole power n. Now replacing all these things here, we get minus 1 by pi, and this term is minus of minus 1 whole power n by n plus 1 whole square, then minus of minus will become plus, so 1 by n minus 1 whole square, and there is a minus 1 whole power n also, then minus 1 by n plus 1 whole square, then plus 1 by n minus 1 whole square. Now we can group the terms. The denominator n plus 1 whole square term, we can group it together. So this is minus 1 by pi. I can take common denominator n plus 1 whole square, and this is minus of minus 1 whole power n, then minus 1. Then here the common denominator is n minus 1 whole square, minus 1 whole power n, then plus 1. From this term we can take the minus sign common. So when the minus sign is common, it will become minus 1 whole power n plus 1 by n plus 1 whole square, and here minus 1 whole power n plus 1 by n minus 1 whole square. Now totally this term can be taken outside, that is minus 1 whole power n plus 1 can be totally taken outside. Outside there is a minus 1 and there is a pi also. After taking this outside, we have minus 1 by n plus 1 whole square, and this is 1 by n minus 1 whole square. We are going to take LCM. So this term we keep as it is, minus of minus 1 whole power n plus 1 by pi, and here the LCM is n plus 1 whole square into n minus 1 whole square. Now in the numerator it will become minus of n minus 1 whole square plus n plus 1 whole square. We took LCM here. We are going to simplify further in the numerator. So here it is, outside terms are as it is, we are writing it. Then here if I expand this, it is n square minus 2n plus 1, but there is a minus sign outside, so it is minus n square plus 2n minus 1, and this is n square plus 2n plus 1 whole divided by, this can be written as n plus 1 into n minus 1, both are having square, so I put a common square. So minus n square plus n square, minus 1 plus 1 we can cancel. So we have 4n. This is minus 1 whole power n plus 1 by pi 4n by, we can multiply this. This is n square minus 1 square, a plus b into a minus b, then we have a whole square. Now we got bn. Bn is minus of minus 1 whole power n plus 1 into 4n by pi into n square minus 1 whole square. But when n is odd number like 1, 3, 5, dot dot dot. Suppose if I have minus 1 whole power odd number, then plus 1, this will become minus 1 plus 1, it is 0. So the value of Bn will become 0 if n is odd. In the same way, if n is even like 2, 4, 6, dot dot dot, so minus 1 whole power 2 plus 1, this will become 1, 1 plus 1. So 2. So already there is a 4. So 4 2s are 8. So minus 8n by pi into n square minus 1 whole square. So this happens when n is even. So we get the value of Bn, which is 0, and another term if it is even. Since the denominator is n square minus 1, when n is 1, what happens is the denominator becomes 0 and Bn does not exist. So for that purpose, this term is applicable when n is not equal to 1. So I have to find B1 separately since the value does not exist when n is 1. So I have to find B1 separately using the similar formula 2 by pi integral 0 to pi f of x into sine nx, but n is 1 here, so sine x dx. So replacing f of x, we get 2 by pi integral 0 to pi f of x is x sine x, and also we have one more sine x here, then dx, so it is sine square x. So now this is 2 by pi integral 0 to pi x into 1 minus, actually we will write sine square x, then we will replace the formula. So it is sine square x dx. So it is 2 by pi integral 0 to pi x into 1 minus cos 2x by 2 and dx. So we can cancel this 2 and 2. So we have 1 by pi outside integral 0 to pi x into 1 minus cos 2x dx. We are going to use Bernoulli's formula. So this is u and this is v. U equal to x and v equal to 1 minus cos 2x. This integration, differentiation of u dash is 1, u double dash is 0. Here this integration is v1, integration of x, 1 is x minus sine 2x by 2. Again this further integration is x square by 2 minus, so minus sign integration is cos, so plus cos 2x by 4. Now we take u v1 minus u dash v2 plus u double dash v3 dot dot dot, and outside we also have 1 by pi. So we keep this 1 by pi. So this is our v1. So 1 by pi, u is x, v1 is x minus sine 2x by 2 minus u dash is 1, v2 is x square by 2 plus cos 2x by 4, and v3, u double dash is 0, so we can stop here and apply the limit 0 to pi. When I substitute pi, this becomes pi into pi minus 0 because sine 2 pi is 0 minus pi square by 2 and cos 2 pi is 0, cos 2 pi is 1, so 1 by 4. So completely upper limit is substituted minus, when I substitute the lower limit, first term is fully 0 because of x, and second term is x square by 2, that is also 0, cos 0 is 1, so we have like this. Now we are going to simplify this further. We have 1 by pi, this is pi square, and this is minus pi square by 2 and minus 1 by 4, and this minus gets cancelled, it will become plus 1 by 4 at the end. So we can cancel these two, and this is pi square by 2, not 4. So we can simplify this by taking LCM. This is 1 by pi into LCM is 2, so 2 pi square minus pi square is pi square. So we can cancel this. So finally we left with pi by 2. So B1 is pi by 2. So our expansion formula, we have to write B1 separately, then summation n is equal to even till infinity, because Bn exists only for the even. So Bn into sine nx. So B1, actually B1 into sine x we have to write, not only B1, because the first term is, generally it is Bn sine nx. So B1 sine x. So B1 is pi by 2 and we have sine x plus summation n is even till infinity. Bn, we have minus 8n by pi into n square minus 1 whole square. So minus 8n by pi into n square minus 1 whole square into sine nx. So minus 8n by pi into n square minus 1 whole square into sine nx. So we can take the constants outside. So f of x equal to pi by 2 sine x minus 8 by pi is a constant which can be taken out. So summation n is even till infinity, and we have n by n square minus 1 whole square into sine nx. This is the required half range sine series.